All right, everyone, welcome back. So I asked you to do the assessment, correct? And to have that ready for today. So remember today they're going to be pulling people out one at a time. And so just have your assessment and be ready to go talk, all right? These are the answers to the assessment. What I'd like for you to do is I'd like for you to grade your own assessment. All right, so I'm going to hand these out and just look over it. And it's, what, 20 problems? So each one's worth 5 points, let's say. And give yourself a grade and put your grade up on the top. All right? So you can grade it however you want to grade it. But don't lie to yourself, you know? There's no sense in you giving yourself 100 when you haven't earned it. But don't brutalize yourself either, okay? Give yourself some partial credit.
What about my kid, sir?
Yeah, just for what you've done. Don't worry about it. But turn in what you have so far. We're going to spend the first, 5-10 minutes doing this. If you have any questions, raise your hand. Somewhere on your page when you're done, first page, you put your grade, circle it real big where I can see it. Make sure your name's somewhere on there. You're fine. So this should be a minus there. So it was a minus, so that would be a difference of squares. So I don't know. What do you think? Out of 5 points, how many do you think you get there? 4 out of 5? Fine.
Yeah, I haven't.
Okay. You recognize that difference of squares?
Yes.
Yes, okay. So hi. We are grading the assessments. So you have yours? Yes. The solutions are just go grab that desk right there.
I was going to ask, I did not reduce that to put a square right there. I just left it like that. Is that?
Yes, that's okay.
That's okay?
Yep. I think on the one right before that, yeah, let's see, on the one before number 6, I said you could write it either way.
Oh, okay.
And so 7 was the same thing.
Okay.
Either way.
No, just number 11 is like, I hope I get this.
The graph?
Yeah, I was like, I did the longest.
Do you find the slope of the line first, or how do you do it? Or do you just plot 2 points and draw a line?
Oh, no, I just... Well,
Oh, wait, hold on. Which one was that? Yeah, so you have to solve for y, or...
yeah.
It looks like you got it. Yeah. Yeah, that looks good.
We just kind of, we got the right answer, we just kind of forgot to see.
-5.
I mean, that's 1/3, but I was like, I didn't.
Oh, yeah, no.
That's the
I
same
wouldn't-
thing.
Yeah, no, it's okay. On a test, I wouldn't take off for that.
Okay.
Yeah. Is anybody done? Is anyone through? Yeah? Eric? Okay. Would you, anyone who's done want to volunteer to go out there first? You want to go ahead? Maggie? Let me see. They're correcting their assessments, and as they finish, is it okay if I just, okay. Go ahead, Maggie. This is Maggie. We're only doing 2 at a time. Eric, do you want to go out there? Or do you want to wait? Yeah? Yeah, just take it. They already have a copy of that, so. Okay. I am going to collect this as a quiz grade, yes. But just keep it, bring it back, and I'll collect them after we're done here.
How much is each question worth?
You're grading on 5 points each?
Okay.
Yep. Okay, well,
I got that instead of that.
you just didn't have the I come out, so you're okay.
Okay.
Yeah. So don't take anything off for that.
Well, for this one, I got this. It was completely different. So I don't know if it's the same.
Let's see what you did.
I just did
Minus one on-
0 product. I don't know that qualifies.
The problem is these two don't multiply to be that original one. See, you have x squared minus 2x. Was it plus 1 or minus 1? Minus 1?
Equals 1.
Yeah. But you brought the 1 over, and you had this, right?
Oh,
Right? That's what you had done?
yes.
Yes? Right here. That's what you had? Okay, and I think from there you put this, and that's not. So this won't work. If you try it, you get here times here, you get x squared. Here times here, you get negative x. Here times here is positive x. Then here times here is negative 1. And these two cancel, and you don't get negative 2x. So that's the problem. This doesn't factor this way, so you have to use a quadratic formula. That's your only option on it. Anybody still need more time for this? No, they're only taking 2 at a time, so from here on out they're going to start calling people out just randomly. Okay, thank you. Are they going to call for the next person? Did they tell you anything?
They didn't tell me anything.
Okay, so let me see. Do you want to call them in? They're all done, so if you want to start, you can just call them in, I guess.
I can do that.
Okay.
Okay, how about Valerie?
Valerie. Dun, dun, dun.
I'm just starting to talk to us.
Okay, thank you. All right.
Okay, I got this one wrong, but I knew what I missed. I just wrote the wrong number down.
All right. Well, don't beat yourself up about it. Look, remember, the whole point of this thing is to give you a sense that you're either ready for this or you're not. That's what it is. The quiz grade, I just want to make sure everyone did it. It's not fair to give someone a 90 and another person give them a 90 and then they didn't really even do anything. You look at you assess yourself here. Do you feel good about this? Or are you looking at the key going, holy sh**, I'm so far off from this. Maybe this isn't the right thing. It took me 40 hours to do this. The person next to me took them 2 hours. So it's a self-assessment here. All right, but we must keep going, huh? Keep them. I'm going to wait till everyone goes out and comes back. I will collect them at the end of class. In fact, why don't we do this? When you leave class, just drop your assessment on my desk, all right? Your graded assessment. I don't have a stapler. I do not. You could, after class, you could go out across the lab, staple it, and come back. All right, but the show must go on, so we are going to continue reviewing now, and unless there were any questions over the homework problems or anything else. I know. You just get on Canvas and you'll get caught up. So no questions? I want to add one more thing about this outside and whatever they're saying to you and stuff. If you feel good and you want to be here and you want to give this a shot, you know, you have every right to be in this class. You know, they cannot force you to do anything you don't want to do. All right? So, you know, but if you're on the fence and they're kind of telling you things that are obvious, you might want to really consider that. All right? But I just don't want people jumping out of here because they, you know, felt like they had to leave the class. That's not the point of it. All right, so what I'm going to do today is I'm going to review. We have on our schedule, we're supposed to do R4, R7, and R8 today. And R4, in my opinion, is very easy stuff. In fact, you can't do R7 unless you know how to do R4. So what I'm going to do is I'm going to start in R7. And so if you know how to do the stuff in R7, R4's homework should be pretty easy for you. R7, though, there's a lot going on in R7. So let's start getting our hands dirty here. R7 has to do with rational expressions. What does the R stand for again? Review. So again, that means that I'm hoping that in sometime in your life, you have seen this before. Maybe it's been a while, and that's why we're going to talk about it, because there's little pieces of things that you need to remember. And these topics in R7 will not go away, especially if you're taking Calculus 1. Show of hands. It's probably everyone, almost everyone. I tell my Calculus 1 students that Calculus 1 is algebra on steroids. That's what it is. It's intense algebra. The concepts of calculus are not that far out there. You know, you have a couple of theories, you use these formulas, and yeah, it gets a little bit messy, but what gets all the students in calculus is the algebra. And a lot of it is rational expressions. So let's see what we're talking about. I'm going to give you a rational expression here. I'm going to ask you to reduce it. So, example, I'm working straight out of the book, so I'll tell you what problem I'm doing. I'm doing number 15 out of the homework set. Now, your homework set is not you're not doing number 15, you're doing number 14, but I'm doing number 15. So that way you have something to kind of compare it to. You have x squared plus 4x minus 5 over x squared minus 2x plus 1. The instructions here are to reduce this into its simplest form. So rational expressions comes from the word ratio, meaning fraction. So we have an expression, right? Not an equation, an expression. So there's no equal sign here. An expression involving the ratio of, in this case, this is a ratio of polynomial terms. And we want to try and clean it up, make it look nicer. Can I do this? Well, that's a huge, huge, huge mistake. Very common, but it's not allowed. For the same reason that if you have 4 plus 5 over 4 plus 1, you can't cancel these 4s, right? Understand? So our only hope to cancel anything is if we can somehow turn these things into multiplication. So if I would have instead put 4 times 5 over 4 times, let's say 2, then could I cancel the 4s? Yes, if there's multiplication in here. So I have to turn this into multiplication in order for me to be able to reduce or simplify. Well, how do we turn 3 terms like this into multiplication? We factor it, right? We factor it. And that's part of what your assessment was on. Can you factor this? Can you factor the top? Can you factor the bottom? And you know, that's a question you're going to answer yourself. Can you do it? How quickly can you do it? But I assume everyone in here can. So maybe it's a little scratch work you're doing on the side and you figure it out. But we know that the top turns into what? And the bottom turns into what? Okay. And the bottom?
X minus 1.
X minus 1 again. Right? That's it. So if that step right there takes you, 2 minutes on the side, that's fine. If that step takes you going to the tutoring lab, you're in the wrong class, all right? Hope that's clear. So that allows us to cancel, right? So we can cancel one of the factors like this, and we are left with x plus 5 on top and x minus 1 on the bottom. Now can we cancel the x's? Still can't because there's addition. But there's nothing else we can do. We can't break this apart any further. So we are done. That seem okay to you? All right. Come on through. The next one I'm going to look at something like number 28. So same instructions. We want to reduce this, clean it up. 12x over 5x plus 20 over 4x squared over x squared minus 16. Here we go. This is what's referred to as a complex fraction. It's a fraction that contains fractions, and we want to be comfortable cleaning this thing up. Now, I want you to notice that I have, 3 division bars here? You'll see 3 division bars? Are the lengths of my division bars the same? No, and they're not in the book either. Okay, and that's important because we all have to understand the order in which things have to be done. Let me give you an example. 4 divided by 2 divided by 2. What is that? 1? Any other possible answers? 4? You could do 4 divided by 2 first, which would be 2, and then divide that by 2 and get 1. Or you could have done 2 divided by 2 first, which would have been 1, and then divide 4 by 1 and get 4. So there's 2 answers here, depending on how you do it. I need to somehow tell you which division you should do first, right? So I need to make one of these bars longer than the other. That tells you you do this one first, then that one. Understand? Same thing here. So I want to do these 2 separately, right? I don't do these 2 together. Got me? Go ahead, Carrie.
Eric?
Eric. Yes, Eric.
Sandra?
All right, any ideas, any suggestions, recommendations?
Factor the square bits?
You want to start factoring like this piece here? Is that what you're?
That and the one above it, yes.
Um,
Possible, of course.
This single term, so there's really no factoring to do. This one could be factored, 5x plus 20 plus 5. Okay, so yeah, there's some stuff we could do that. Let's go ahead and do that. Let's go 12x, 5 pulled out, long division bar, 4x squared. I can't really do much to that. And on the bottom, oh, what is x squared minus 16? Difference of squares, so x plus 4x minus 4. So in this class, 1414, day 2, we should all recognize the difference of squares. Remember I was just saying calculus is algebra on steroids? We all recognize that as a difference of squares? Let me give you a quick example of something in calculus. Is that a difference of squares? No. Well, not in this class. In calculus, oops. Would this be true? Let's see. What's the square root of x times the square root of x? X. What's root x times negative root 3? like negative 3 root x, something like that. So if I multiply this, I get x minus root x times root 3. That's here is this. Here is this. Here would be plus root 3 times root x. And then the last one here, positive and negative is negative. Root 3 times root 3 is 3. Do you see the middle terms cancel? Yeah. Okay. It's x minus 3, so it's this. So it is a difference of squares, but see, in a class here, we don't mess with that. In calculus, you do. It's an extension of stuff you've already seen. So that's what I mean. Everything's just amped up in calculus. So we have to be comfortable with this if we're ever going to be comfortable with something like that. All right. So I've done what you recommended. Who recommended that? Oh, you don't have a name thing. Let me give you a name thing. Anyone else need a name?
It's never been the FNG around here.
What?
FNG, that's the new guy.
Okay. There you go. All right, what now? I agree with that, but you know, what are we gonna do with that? Cancel? How do you want me to cancel? What can I cancel? Go ahead.
Group the top and the bottom together and the middle together. So you can multiply the top, the very top and the bottom, and that becomes the new numerator.
Okay, so yeah, I think what you're doing, what you're suggesting is, I think what we all know, but maybe don't know how to say. If you have a fraction over a fraction, right, you can flip this fraction up and make it multiplication. In other words, a reciprocal multiplied by the reciprocal. If you do a over b divided by c over d, this is equivalent to a over b times d over c. That you can always convert division into multiplication as long as you multiply by the reciprocal. So you leave the top fraction, this one here, you leave it alone, you bring this fraction up here, but you flip it over and you make it multiplication. So that's what I'm going to do on the next line. I'll do it right here. So I leave the 12x over 5x plus 4 times x plus 4, x minus 4 over, go ahead, 4x squared. Right? We good with that, or questions, comments? We're all right? Okay. What can I do now?
Can you cancel out the x plus 4?
Okay, so can I? Am I allowed to cancel these x plus 4s out? Yes, because that's multiplication, right? So I can? I mean, you could group it all together. You could get rid of the dot. You could just make one line going all the way across now, and now everything cancels out. Well, the x plus 4s would cancel. Is that the only thing that cancels out? You could reduce, right? 4 goes into 4 once, 4 goes into 12, what, 3 times? Anything else? A single factor of x, right? This is x to the first power. This is x squared, so we can clean that up. What's going to happen here is that's gone, right? And this x squared is going to become an x to the first power, isn't it? So at the end of it all,
X minus 4 over 5x.
3, right? We still have the 3, so 3, and then in parentheses x minus 4 over 5 times x, so 5x. So 3 times this, so we got to keep it in parentheses, and then 5 times the x that was still here. Is everyone clear on that? You could also, at this point, multiply this 3 back through, but, I mean, we've cleaned it up. I mean, you could write 3x minus 12 over 5x, but that would be no more correct or less correct than this answer. I will accept it either way on a test. Okay, how about I give you one to try? This is All right. Yeah, you try this one. This is number 34.
Isaac.
Go ahead. Wearing a shirt like that, I'm surprised you didn't fall and break your collarbone. Sure. Cowboys.
Oh, yes. It's quite unfortunate.
Okay, so everyone's going to work on their own on this one. I'll give you a few minutes. If you have a question, please raise your hand. I'll come by and take a look at what you've got.
Okay, Joseph.
Abby, you all right? Okay, I just want to make, because everyone's like writing and you're just looking. So can I see? All right, so you're comfortable with breaking all those down then?
Yeah.
Very good. Okay, okay. Good luck. Whatever you go through, okay. Are you telling me you're done, or you have a question?
I'm just not sure if that looks right or not.
It looked right. That looks right to me. I'll double check it. I'll put the answer up. In fact, I think what I'll do is I'll put the answer on the board so you can see if you're getting it. So in red up there on the board is what you should be getting after everything's cleaned up. And you could multiply these all out again, but we like to leave them factored for what would come later on in a different class.
Robert?
I'm good. I'm going to stay. I'm going to stay in. Okay, quick show of hands. How many of you are done? Okay. All right, let's move on. Before we get into the next group of problems, which there's going to be a slight change in what's happening here, I want to talk about this expression. This is not an example in the book or anything, but this will come up for us. if you have x plus 1 over, or sorry, times x minus 2 over x minus 1 over 2 minus x. Can you simplify that at all? Can you clean that up? Can you cancel anything out? Or is that all the way? It's all the way?
2 minus x and the x minus 2.
The 2 minus x and the x minus 2?
Negative x and the negative 2 on top.
But you can make it at x minus
Yeah, factor out.
pull out the negative.
Okay, so let's talk first about the x plus 1 and the x minus 1. You can't factor these, or you can't cancel these because they're not the same, right? This is a positive x, or it's an x. This is positive x also. This is plus 1 and minus 1. So the x's are the same, but the numbers are off by a sign, aren't they? Positive 1 and negative 1. Over here, your x's are off by a sign, aren't they? Positive x, negative x. And your numbers, negative 2 and positive 2, are also off by a sign, right? So what you can do, and let's just look at the bottom factor over here by itself. Do you agree that this is the same as negative x plus 2? Is that the same factor?
Yes.
Yes? And then, is this the same? Can you pull a negative 1 out and change it to x minus 2? So if I push this negative 1 back through with multiplication, would you get back this? Yes? And that is that? So I can actually transform this into this, can't I? And then what's in parentheses x minus 2 would match with the top, right? So what everyone needs to see in here is that these two factors are almost the same if you are willing to pull a negative 1 out of the bottom factor, which you can always do. You can always factor a negative 1 out. So that's what I would do on this next step. I go x plus 1 times x minus 2, and then I'll put, well, where's the negative 1 that I'm going to pull out of here? Where should I put it?
In front of the x minus 1.
You can put it way out here in front of the x minus 1, like that. Okay, you're allowed to do that. And then have the x minus 2 here. Does everyone see that? This negative 1 just kind of popped out in front. And now you're free to cancel.
Draco?
Oops. X plus 1 over 1 minus x. What happened there?
You just distributed the one.
I took that negative 1 and I said, oh, okay, well, while it's sitting out here, I may as well just pass it through the other one. And then that turned into this. So this is the sort of answer that you would see in the back of the book. And then maybe you're working through yours and you're here and you're like, what happened? I'm so off. No, you're not. You're almost there. It's just one simple step. Shouldn't say simple. One more little step and you would be there. All right? Just be ready for that to pop up. The thing you're looking for is for your factors to be off by a sign. Your x's have to be off by a sign, and your 2's here, your number has to be off by a sign. All right, let's look at something else. Another example. Please keep in mind that I did say that we really haven't started new material here, right? So this is not the way the whole class is going to go. I'm just going to start just doing homework problems the whole time. I mean, there's going to be theory, right, in this class at some point, just not yet. All right, number 44. So 5x minus 4 over 3x plus 4 minus x plus 1 over 3x plus 4. So what's the difference between this problem and everything that we've done up to this point?
Yeah, there's been division, whereas now we're adding or subtracting.
Yeah, we've been doing division, now we have subtraction, right? We have a rational expression here, we have a rational expression there, and we want to subtract the two. So these are two fractions we want to subtract. And what's the big rule that we have to have, or the thing that we have to have if we're ever going to combine two fractions together with addition or subtraction? Same denominators, right? You have to have same denominator. In this particular case, we do. So we got lucky, right? So all you have to do is combine the numerators together, but you have to be careful with this minus sign, because whatever signs here must transfer over to both of these, right? However many terms there are here, that negative is going to apply to each one of them.
Then it would be 4x minus 5.
I'm going to go a little slower. 5x minus 4 is these, right? Then minus x, then minus 1, and then over the 3x plus 4. And then in the top, you just combine like terms together, and you get 4x minus 5 over 3x plus 4. And you can't go any further with that, right? So we're done. That's pretty clean when we have the same denominator, right? So we should see what happens when we don't have the same. That's where things get a little ugly, right? So how about number 48? 2 over x plus 5 minus 5 over x minus 5. They're almost the same denominators, aren't they? Almost the same. Are they off by a sign?
Yes.
Are they off by a sign? Almost, not quite though, right? They're- yeah, the numbers are off by a sign, but the x's aren't. If it was, then we could maybe do a factoring of a -1, and we would have the same denominator. Go ahead, Carrie.
Daniel?
Daniel. All right, so if we don't have the same denominator, we have to create the same denominator, right? So we have to multiply both of these fractions by a 1. And the 1 must make it so that each of the denominators match up on both fractions. So I'm going to imagine a little 1 over there. What is it going to be? What am I going to use? Whatever I'm missing. So x minus 5 on the top and bottom. I'm multiplying the first fraction by that. And then minus the other fraction, what am I going to need on the top and bottom over here? X plus 5. And
Okay, Lindsay.
Lindsay? No? No? No Lindsay?
Okay. Caleb. Caleb?
He's coming.
Oh, okay.
Does this look like the way you might do it, or algebraically? I mean, you could have put this one on the other side of that. It's multiplication, so it doesn't matter which side it's on. The key to it is that you multiply out the numerators properly. So I have a binomial times 2, so I must distribute that through. I have another binomial times 5, so I have to distribute the 5 through. And the denominator, do you want me to multiply them together or just leave them? You want to leave them? Let's leave them, right? In case we have to cancel later, we won't have to go undo what we just did. So 5x, that's right. Don't work hard, work smart. Did everyone see that on our Canvas page? Did I put that quote on there? Don't practice till you get it right. Practice till you don't get it wrong, or you can't get it wrong. I saw that the other couple of weeks ago, and I was like, man, that is an awesome quote. Math is one of those subjects where it's not like you work through it and you do a problem, you're like, God, I finally got the answer. Yes. Now what you need to do is you need to do about 30 more of those until you don't get it wrong. That's when you've actually reached it, okay? We'll talk more about how how you're going to prepare for the test, and studying and That's one of the skills I see in classes like this. Students will, they follow in class, they understand, they do their homework, they do okay, but when it comes to the test, they don't prepare properly. And it's different for every student, but it's worth talking about. Like how are you just going to sit up and just look over some stuff for 30 minutes before the test? Or are you going to sit in a quiet room for an hour and 40 minutes and start a clock and give yourself problems? I mean, it's going to depend on you, right? Is that a raising of a hand?
Yeah,
Okay,
sorry.
go ahead.
Quick question. Do
Yeah.
you normally give reviews or just like, okay, well, this kind of stuff is just going to be on it?
I've given some sort of indication as to what's going to come. I've given some sort of review in the past. I'm not against the idea of having a review. The only concern with the review that I have is that as you move on and you do pre-cal and cal 1, I mean, there's kind of like, they just become less and less. The problem with reviews is it narrows your focus too much, and it doesn't help you become a good studier.
Student, I think. Right. I see what you're saying, though. Basically, it focuses our study for that one, and then we just kind of forget
That's
it.
right.
And move on.
That's right. And the further you go on, no matter what it is, math or nursing or whatever it is that you're doing, the reviews, they go away. And so what it is you have to be able to understand all the material, and it's up to you to kind of put it all together and make your own review from it and study. Yes?
So then, would it be the wrong approach to just constantly really get problems that are like solved the same way?
Yeah, kind of like what I'm doing here. I'm looking at your homework problems and I'm picking problems near them that look the same. And that's what you should do. You should do your homework.
Okay, so that is
And
the
then
correct approach then.
I think with mathematics at this level, you have to have repetition. You have to have repetition to become comfortable with it. What the drawback is that as we progress in the class, the problems become longer and longer. And so there are problems that'll take you like 45 minutes to do one problem. So you can't really do 30 of those, there's not enough time for it. But you do enough to hopefully feel comfortable. I think the most important thing with studying for a math test, on top of, have you reviewed the material, is have you actually put yourself in a testing environment. Like, put your books away, you come up with a set of problems on your own, you go into your homework set, you pick like problems that I assigned, and you say, okay, I have an hour, 40 minutes, go. And see how long it takes you to do those problems. And did you, were you stuck? If you were stuck, what were you stuck on? Do you write that down? Go ahead, Carrie. Let's talk more about how you can approach tests as we get closer to one. Right now, we're just making sure like everyone's comfortable in the class, right?
Sorry for digressing.
Yeah. No, I was the one who brought it up. All right, so we have the same denominators now. We just combine the numerators. I'll do this one in one step. We're going to have 2x minus 5. We're going to take away 5x, and we're going to take away 25, right? Minus 30. 10. Oh, I didn't do the 10. Thank you. Abby? Yes. See, I will start to learn names. It's going to be a slow process.
Oh, yes, 'cause I was just.
Minus 30. I wrote it down wrong. It's my fault. I take full blame for that. If y'all see something obvious like that, just don't be afraid to point it out. All right, so how does that change things? Negative 35?
Yes.
Okay. And then over the common denominator?
We would accept it like that, on a test?
Yep. As long as nothing else cancels. And I don't believe we can do anything else to this, right? We can't pull anything out of the top. We could pull a -1, but we couldn't pull like a 3 out or 5.
Or
So we're stuck at that point. It's as simple as we're going to get it, simplified. All right, let's try something else. Have you ever heard the term turning the screws? You'll hear me say this throughout the semester. I say, okay, now we're going to turn the screws. I believe there used to be like a torture device where they'd put people on like a rack and they'd tie them up and they'd start stretching them out. You know, you better tell us the secrets, you know, and then they wouldn't, you know, they wouldn't talk, so they would turn it a little more. They turn the screws, just a little more pressure, right?
Good way to straighten your spine.
Yeah, so that's what we're doing. We're just applying a little more pressure here now, seeing if you're going to give up the answers or not. Okay, x over x minus 3. I want to take a quick vote. Don't be shy. How many of you actually get a little, just this little like adrenaline kind of happy feeling when you get a math problem right? Anyone here? Is it more like a relief? Yeah?
I kind of showed it a couple minutes ago.
A little bit of a, like the light bulb goes out and you feel that little joy just for a second. Who did? Caleb, you didn't raise your hand. No, not at all? Not happening. Okay. All right.
I was doing the homework last night that was due on Tuesday night. I finished. I was like, yeah, I got it. I didn't even need help. She's like, well, I was like, what are you talking about? I finished all my homework. She's like, okay.
Yeah. See, we're getting into weird territory when we're celebrating things like that. But you know, that's part of. Hopefully, that's something you can find, because I think you need that, right? That little reward, that little treat at the end. It sucks when it doesn't come, though. When you work hard and you're not getting it. That's what makes people hate math so much. And that little reward that you have, believe it or not, I mean, when I studied math in graduate school, like I would suffer for months on a problem, and then just for that finally getting it reward. And that feeling felt better and better the further along I went. They came less because the problems were so much more complicated, but the reward was so much better. I had an old professor who told me once that the reward of proving a theorem was only second to his child being born. And he was married, so that he was putting his marriage behind this. It was only his child that he put in front of the reward of the feeling of proving something in mathematics. So, you know, even at this level, I think you understand that feeling as you move on, you know, in your field. I hope that's what you're chasing. You're chasing that feeling still. That's the reward. So, all right, let's see if we can reward ourselves here. What am I gonna do?
I would.
Nothing looks right.
I guess you could start factoring that bottom beta.
That's what I would. That's what I started doing.
Yeah, if you're going to combine these together, it's subtraction. You have to have the same denominators. And because one of the denominators is quadratic, it might be useful for us to factor it, because maybe one of these factors already matches with this, and then I don't have to create this disaster, because I could right now, it would not be wrong for me to multiply top and bottom right here by x squared plus 5x minus 24, x squared plus 5x minus 24, and then over here, x minus 3, x minus 3. That's totally fair, legal algebra, but it might be more than what you need. So instead of doing that, I will try and factor out. Do you understand what I just said?
Yeah.
Okay. So I'm going to do x over x minus 3 minus x plus 1 over x. Does it factor?
Yes.
Okay. What is it?
Minus 3x plus 8.
Minus 3. Oh, we got lucky. Plus 8. So that means the only thing that they both don't share. Go ahead. I'm staying. I'm staying. No? Anybody not go out yet? Let's see. Rogelio and Steven's new to the class, so he's probably not on your roster, but you came from 13, 14, right? So I think you know you're in the right place, right? Okay. Okay, so I'm going to take this, and now the only expression I need to work on is this first one, right? So
Multiplied by x plus 8.
x plus 8 top and bottom? Okay. So I'll do it in red, top and bottom. When I put these two together here, distribute, right? Distribute that x. Don't need to do anything to this one. So now we're looking at x squared plus 8x over the common denominator, which is x plus 8 times x minus 3, and then minus x plus 1 over x minus 3 times x plus 8. What's the final answer? Does it?
I don't know if I got the final answer, but after
Okay, so what do you have?
x squared plus 7x minus 1.
X squared plus 7x minus 1 over the denominator, right? So I guess you said you're not sure if you're all the way because maybe you're thinking the top might factor out or break up, and it does not. So that would be it. Okay, I think that's everyone. Let me just double check that they've talked with everyone. We good?
Yeah.
Okay, thank you. Okay, so this is it. This is the team. You made the team. This is going to be our group, so. You know, I was kind of against this whole weeding out thing that they're doing when they first started last semester because I thought it was kind of a bad idea. But from my perspective, once this part happens, usually everybody in the room is invested in this, is serious about being here. Whether or not they need it for Cal 2 or for, you know, nursing or, you know, whatever it is, you want to be here because you want to get through the class. So when we used to not do this, you would have a good mixture of people who were just like,
Tell you what, though, there's definitely doom and gloom out there.
what's that?
Definitely doom and gloom out there.
Yeah, well, it's the right thing for people sometimes to just go back a class and just get up to speed. I mean, if you can't factor this, I mean, yeah, well, no. We didn't have to factor that, did we? Did we? Earlier, did we factor it? Yeah, we factored it earlier. That was so long ago. If that takes you 20 minutes, I mean, honestly, how are you going to do on a test? All right, well.
Time's taken up by factoring 5 different things.
Yeah. Yeah, because one of the problems we did that I asked you to do on your own, you had to factor 4 things, right? So. All right, so let's see if we can continue to turn them. Okay, the following expression is something that you would see in in a calculus class. So let's see how you do with this expression. It's not in the book. I'm just kind of making this one up. 1 over x squared plus h. You know what? Change. 1 over x plus h squared minus 1 over x squared over h. Simplify that. What does that look like to you? I mean, does that look intimidating or?
At first, yeah.
Yeah?
A little bit at
right, so how do you want to attack this?
Can we assume that the h in the bottom is h over 1 and just flip it into multiplication like earlier?
You could, yes. You could assume that this one down here is an h over 1, and then you could flip it like this. We could. That, I'm not going to say that's wrong. That is correct. Let's hear any other suggestions on what you would want to do.
I would work on the top one first. Since
Okay.
it's a subtraction problem.
Okay, so you're working on maybe trying to put those together first and then going to the step of flipping. That's okay too? You know?
That's what I was.
So how many of you would think you'd work with the top one first, the top piece? Yes? Okay, let's do that. But recognition of the fact that this is h over 1 will be essential later. Okay, so let's try and put those together. How are you going to put those together?
Writing out the whole x plus h.
You want to multiply that all out and get a big old ugly thing there? You can. Do you have to? You have to get a common denominator, right? You have
Can we
to.
factor out that square?
Yeah.
Can we factor out the square?
Factor out the squared. I'm not sure I know what you mean.
Denominator.
Right, so you still end up with a big.
What, I'm not sure what you mean by factor out the squared.
Meaning.
Factor out, I think.
Trying to,
You just have to combine them.
I guess it is what it is.
Like x squared times x plus h squared.
I guess you can do that.
So remember, I'm saying calculus, algebra, steroids. It's a matter of the thing that trips people up is, can I do that? Like, am I allowed to do that? You know, like, can I actually do what I want to do here? And that's where you have to get very comfortable with the algebra in order to know whether or not that's a good or a bad thing to do, like legal or not. Remember, we're trying to get from point A to B. I said that last class, right? Point A to B. And there are many paths, okay? You could do the 1 over h over 1, flip it, and you could do that. That's one path. You could work with the top. But as soon as you break a rule, an algebraic rule, you're no longer on a path to B. Now, you might stumble upon it drunk accidentally, but the probability of that happening is pretty low. You might re-break a rule and find yourself back on another path, but as long as you don't break a rule algebraically, there is some connection between the answer and where you are. Drunk, intoxicated by the mathematics. I'm not talking about alcohol. So I should clarify these things. All right, so let's work with the top. Should I just show you what to do, or?
Please.
All right, let's do the common denominator. I heard it over here. This is correct, Sean? Okay. What we're going to do is we're going to look at this. This whole thing is one denominator, and this whole thing is the other.
Right.
So we're going to need both of those in the denominator. So I'm going to introduce over here on the top and bottom what? X squared, x squared. And over here, x plus h squared, x plus h squared. That's what I'm going to do.
Okay.
All right? So I'm going to have x squared over x squared times x plus h squared minus x plus h quantity squared over x squared times x plus h quantity squared, the entire thing over h. I will just highlight again the part that I introduced, right? In red. That's what I introduced. I introduced x squared over here. I introduced x plus h squared over x plus h squared over here, which were really just 1, so it doesn't change the problem. But it gives me the same denominator, doesn't it?
Yes.
Now we put them together, don't we? Put the two together. So we'll have this. Is there any question on what I've done?
No.
No?